Hi, year 12. Today I'm going to continue with binomial cumulative distribution because I got quite a few messages saying that it was tricky, so there's no point moving on if we're not confident on this. So I'd just like to go back to example 7 and explain where the probability comes from. So actually work it out the long way and then do it in your calculator, just so, because it can be really confusing if I just tell you to type this in your calculator and bang, there's your answer. You need to understand where that number comes from. So I'm going to do example 7 the long way and then do it the quick way in the calculator. So we saw that in my last video I went through this as well. The spinner designed so the probability that it lands on red is 0.3 and she spins it 12 times. Let's find the probability that she obtains no more than 2 reds. So we can say that x is the random variable of getting a red, and we can say that it's binomially distributed and the number of trials is 12 and the probability is 0.3. Probability of success, that is, so that's the probability of getting a red. So no more than 2 reds is the same as saying the probability of 2 or fewer reds. So we want the probability that x, the number of times we get a red, is less than or equal to 2. Well, what are those individual probabilities then? So that is equal to the probability that we get 0 reds, the probability that we get 1 red, and the probability that we get 2 reds, and then add all them together, because that will give us the probability of getting 2 or fewer. So to work that out the long way, well, we know that we can do NCR times the probability of success to the power of how many successes times the probability of failure to the power of how many failures. So NCR in this case will be 12C0, which is 1, times by the probability of success to the power of 0, because we're saying that the probability, it never happens. We never get a red in this case, times the probability of failure to the power of 12, because it happens 12 times. And the reason that NCR is 1, because that's the number of combinations you can have for how can you possibly get 0 reds. There's only one way to possibly do that, and that's to get anything other than red 12 times. So really that probability is just 0.7 to the power of 12, which is 0.0138412, and I'll just go to there. So let's do the same thing again, but for one success this time. And if you're not sure where this comes from, this NCR thing, then you need to go back to last Tuesday's lesson and just run through that again quickly, go through some of the integral walkthroughs, and yeah, that explains where this comes from, or it's on page 88 and 89 of your textbook. So let's type that into the calculator. So 12, then to get the C, we need to do option, go to the right one, then prob, then NCR. 12C1 times 0.3 to the power of 1 times 0.7 to the power of 11 is 0.071183 blah 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 blah. Okay, final one. So I'm just going to go back to my previous line of working in my calculator and change some of those numbers. And the probability of getting probability of getting 2 reds across 12 spins is about 17%, or 0.1677, blah blah blah. Now I need to add all these together. So answer, add 0.0711837 plus 0.01384112, and you get 0.252815, blah 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 blah. And what you should notice now, if you look at that in the book, that is the same as the answer in the book. So that is where the number comes from your calculator. It's doing all of these calculations that we've just done for you, and then adding them all together. So just to run through how you get that the quick way in your calculator, you need to go to menu, then 2, so quick way. And I'm doing this on the calculator that I've got, so the bigger, more expensive one. You need to go back and watch a video. Again, I think that's in Tuesday's lesson. If you've got a different calculator to that, or just Google your own calculator and say how to find cumulative probability, binomial in Casio, whatever you've got. So you need to go to main menu, then 2, then press dist for distribution, which is the F5 button, then F5 for binomial, and then BCD because we're doing cumulative distributions, cumulative because we're adding together different probabilities here. So let's see how we get that in the calculator. Well, this time our lower limit is the lowest probability, not the lowest probability, but the lowest number of successes that you want. So the lowest number of successes in this case is 0 reds. So for low you put 0. Upper is your highest number of successes that you want. So that's 2. And then the number of trials is 12, and the probability is 0.3. And then you just press execute from there, and you can see that from your calculator it gives you the answer of 252815, blah 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 blah, which is exactly the same as this. So that shows you that this is all the working that's sort of going on behind the scenes in your calculator to get that number. So I hope that clears that question up a bit and that where that number is coming from. So we're saying that getting 2 or fewer, the chances of that are about 25%. Okay, the other one I'd like to go through is this question here, which again I got a few messages about, which is really good. If you're stuck, then definitely message me by emailing me. So this time the probability of winning £5 on any given bet is 0.05. I decide to play exactly 10 games, find the probability that I will win more than £10. Okay, so the first thing to note is that it's going to be a binomial distribution because there's a fixed probability that is independent of previous goes. There's a fixed number of trials, and there's a probability of success or failure, so winning or losing the bet. So I can say that X is the random variable of winning £5 in 10 games. So we should always say what X is in our case, because otherwise it's just a letter. So we're saying that X is a random variable, and it's binomially distributed. We're going to do 10 trials, and the probability of success is 0.05. Now I want the probability that I will win more than £10. So let's think about how many games would I have to win more than £10. Well, if I won 0 games, then I'd obviously get £0. If I won 1 game out of all of the 10 games that I played, then I'd get £5. But if I won 2, then I'd get £10. So does that fit? Find the probability that I will win more than £10. So no, I want more than £10. So if I win 3 times, then I'm getting £15. If I win 4 times, I'm getting £20. So I can see that anything 3 or more is going to get me more than £10, which is what I'm after. So I want, and you could write this a few ways, I want the probability of getting more than 2 wins, or another way of saying that is getting more than or equal to 3 wins. So what do I do to get that in my calculator? Well, I could go through all the probabilities of finding out equals to 3, equals to 4, all the way up to equals to 10 and add them all together. But I know that that's a very long way to do it, and I'd have to do NCR for all of those times 0.05 to the power of 3 times 0.95 to the power of 7, and so on and so on. So it's going to take me a long time, so I need to use my calculator because otherwise you're wasting time on what's going to be probably not that many marks. So for my lower this time, that's the lowest possible probability, the lowest possible number of successes I want in this case, which is 3, because that would get me £15, which is more than 10. The upper is 10, because if I won 10 games, then I'd definitely be getting more than £10. I'll be getting £100. And the number of trials is 10, and the probability of success is 0.05. Execute that. And the probability that x is greater than or equal to 3 is 0.011503, blah, 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 blah. So I can see that the answer was C. Lots of us put A, or the people that did it put A. And I was trying to figure out why, but I couldn't quite figure out why. So maybe one of you could email me and tell me, or maybe it's just a complete guess. But if you think about it, so if you're getting a probability like A, well, the probability that I win is quite low. It's only 5%. So getting more than £10 is maybe not that likely. So if you're getting something that high, then you might want to just think about, that sounds a bit high, because the probability of winning isn't actually that great. Okay, for the rest of the lesson, I'm going to set you some questions from exercise 6C, or if you feel confident on this, then I'll give you some other questions. But again, if anything's not clear from today, then just let me know. Have a great rest of your day.